Hello, Engineering Glass. Today, we're going to be talking about engineering. So, we're going to talk about it again. And the topic for today is why you would want to go into engineering and what role does engineering really have in society. And we'll also answer why is engineering a critical part of the economy. So, we'll take an extreme view to start out. Okay, just suppose you're playing a game, right? And let's say I ask you to make your own country. What would you need to provide to get like jobs and money and other things? Like what item would you need to have? How would you create value out of those items? And what skills would you need? How would you become self-sufficient in your country and make it really prosperous? I mean, these are some pretty key questions. So the key would be to have natural resources. Now, if you don't know what a natural resource is, just think of rocks, animals, plants, things that you've all seen, right? So rocks, animals, and plants are like money. And to show you, we have three examples. As an example of rocks, we have tungsten ore. For animals, we have sheep, and we also have cocoa tree for a plant. Okay, so I have placed the prices beside each natural resource, and this is just a price it costs to buy these items per ton, and tons about 2,000 pounds. So these resources don't really occur everywhere. There's almost like a lottery. They occur in these sporadic places. And just look at the mineral of tungsten ore. If you want to find tungsten ore, you would have to be in a place like China, Russia, Vietnam, Spain, or the UK. So you may ask, so what? Like, I have no interest in tungsten ore. Why would you even want to have it? Yes, that's the point. When you say tungsten ore, it shouldn't make any sense. It should not get you excited. We really need engineering to make sense out of cheap things that you just find laying around the environment, like tungsten ore and sheep hair. Because sheep hair and tungsten ore are really nothing. They don't really cost that much money to begin with. You can look at the prices, right? So, using engineering, you can convert tungsten ore to tungsten, used for welding tips and cutting tools. And you can also use sheep wool for things like jackets and gloves. And you can also use cocoa for, we can get a cocoa nib and we can convert that into chocolate bunnies and chocolate sheep. Okay, so, and I really hope you're starting to like engineering right now. So, are you really starting to like it yet or no? Yeah? Yeah? Okay, great. Okay, so you can turn anything like a rock, animal stuff, plant thing into something valuable by usually using 3 steps: detach or collect, extract, and convert. Now, detach or collect is essentially taking an item. Extraction is removing the excess of an item to get only what you want. Just think of like eating icing straight off a cake, right? And just throwing away the bread. Because you just want the good stuff, right? So conversion is like using biological or chemical process or conversion to change a material to something a little bit more exciting. So let's just look at this. So you have tungsten right here. Now, tungsten, you can separate tungsten using extraction from the tungsten ore, and that's uses something called specific gravity. A lot of chemists use specific gravity in order to separate the tungsten from the tungsten ore. So you need to study chemistry to allow you to know how to turn that tungsten ore into tungsten. That's why it's so important. Sheep wool goes through different processes like shearing, which is basically cutting off the hair on a sheep, washing, combing, and softening. Softening usually uses like chemicals to soften the material so it's not so rough and doesn't scratch you, right? So all those different processes, they need workers behind them. You need someone who shears. You might have someone else who's in a wash house in a specific area. You might have someone who just has a machine that combs the wool, and you might have someone else who's a chemist, right? They're in a chemistry lab and they're mixing the chemicals, making the wool really, really, really soft. And then you get the wool yarn, which you can buy in any kind of fabric store or kind of knitting store or anything like that. So looking at cocoa, we have a different scenario. Let's look at this. Okay, so we have harvesting, which is when you collect, right? Then we have ferment. It's a biological process, so it's not in the order that I have a detach, extract, and convert, but still in that process. So you have fermentation. It changes it. It goes through a biological process that goes through exothermic reaction, etc. Then you have drying, which is another process. Then you have roasting, which is another conversion process. It changes the flavor profile of the cocoa. And we have winnowing, which is actually the extraction, where you go back a step and you have a machine for this. And you have grinding, you have conching, and you have tempering. Grinding is basically just grinding the big particles into small particles and make it really, really smooth. Conching is getting rid of the excess, and tempering is really aligning those crystals so you can convert it to a little different product where it's a little bit shiny and stable. Now, for all those different processes, like harvesting, you have a machete, and drying, you have a drying machine. Not drying machine like clothes, but a different drying machine. Roasting, you have another roaster. You need electrical engineers and mechanical engineers to build all that. So once you get all your products, now you need to transport them, because there are people around the world who might need them. You might not have too many people in your country. Maybe you only have like 1,000, right? But you have like 1 million trees. Like New Zealand has about, I don't know, like 37 million people, and they have 8 million sheep or something, exorbitant amount. So you can't use all those products on your people. You need to send them elsewhere. So we have transport that we need, that we can add value. Not add value, but we can actually add jobs on top of this. The more products that we produce, the more jobs we can give when we need to transport them, right? So we have air, we have land, we have water. For air, we have planes. For land, we have bridges and roads. And for water, we have ships. Great. So now we also can enhance each of these products. So when I say products, I'm referring to the finished products, right? So how do we enhance something? Each item we get, when we get to the final stage, if we can think of how we can increase or enhance the senses of those products, it'll make the product even more valuable, add more money to our economy, and our country will be richer, and the people will be richer, and they'll be happier. So one of the things you can do, you can improve the sight. You can improve the taste. You can improve the sound. You can improve the feel. How would you do that? Let's just work backwards from the bottom up. So you can improve the sight by changing the color. And you know how you change color? I won't really talk about this too much, but you change color through things like insects and rocks and minerals and things like that. So you can see this kind of cyclic, full circle process. Taste, you can change it by richness and sweetness. Sound, amplification and filtering. So if you have a soft sound, you can make it really loud. If you have a filter sound, you can make filter sound. So you can change it up a little bit. So people seem to like that, depending on what kind of environment you're in. Maybe you're in a horror movie, you need to have a creepy sound. So that works also to increase the value that you have. Feel, you can change the texture. As we mentioned before, you can soften the sheep wool, and you can create more value because people want to wear your clothes longer instead of buying something that's synthetic. Okay, now you can also have conservation, and you can have preservation and mitigation. Now, what does that do? Now, that also adds value, because if you think of something like sheep wool, now sheep wool might not last too long, because let's say you're in a very, very wet environment. Maybe you're in Ireland or somewhere where it rains a lot. So if you're in that kind of environment, your wool might get messed up. So a thing you might want to do is you might create a process to where you can waterproof the wool, right? That's a great idea. So now when you're in the rain and everything, you have waterproofing of the wool. It doesn't mess up, increases the value. People want it more because they can wear it more. That's conservation, preservation, and mitigation. How about for cocoa? What can you do? Well, first of all, the drying process helps it, right? So you lose less product when you dry it, right? And also bug and disease resistance. You can also maybe treat your cocoa with certain things, cocoa trees with certain things, which will save it from being eliminated through disease and rodents and all this other stuff. Oh, wow. So we're getting there. So I just also want to add that a lot of these processes, whether it be like for the cocoa process, for harvesting and fermenting and drying and roasting, winnowing, a lot of these are also improved through automation. Automation is one of the biggest advances in engineering, and that's what a lot of electrical engineering involves. Automation of all these processes to make them more efficient so you don't have to work as hard. And when you have the automation of these processes, you also need to have control and monitoring. Control and monitoring, if you don't have a human who really has a good intuitive sense of how things work, you need to have a machine. But since machines can't think, you have to have all this logic that tells you when things are appropriate, whether it's too hot or too cold, or whatever. So that's engineering, and that's why it really matters in this world. And I really hope you like this series, and I hope you continue following it. Thank you, Engineering Glass. Hello,